All right, well, today we're going to look at mutually exclusive and independent events. Okay, so it's a lot to do with the language here. It can be a little confusing, so hopefully we'll clarify some of that. Okay, so I'll start with an example of, we're focusing first of all on mutually exclusive events. Okay, and we'll start with the example of if we selected one card from a normal playing deck and we had two possible events, okay? And one would be getting a heart, card with hearts, and another would be diamonds. Now they are mutually exclusive because we're only selecting one card and you can only get one or the other. You might get neither, but you can't get both. Okay, so it's a very simple example of mutually exclusive, but I think it makes the point. Okay, now we would probably know that the probability of getting A or B, in other words, a heart or a diamond, well, that's half the cards. So just sort of intuitively, we can figure out that the probabilities are half. But let's see that this actually works. Okay, the probability of getting a heart, well, that's 1/4 of the cards, is 1/4. And the probability of getting a diamond, well, that's also 1/4. So you can see that this little law holds up for mutually exclusive events. Okay. Now let's look at something to contrast it with this non-mutually exclusive. And we'll go with the hearts again. So we're drawing one card and we're going with a 5. Okay. Now, if they were mutually exclusive, you couldn't get both. You'd either get a heart or a card with a 5. But we know that there's the 5 of hearts. So there's one outcome that satisfies both these events, okay? So that means that they are non-mutually exclusive. And if we try to apply the law above, we'll see that it doesn't work, okay? So we've got, if we had PR A or B, then we know that the probability of A, in this case, or if we try to apply this law, we'll see that it doesn't work. All right. So the probability of getting a heart, as we know, is 1/4, or I'll work as in 13 out of 52. And there are 4 cards with 5 on it, and so that would come to 4 out of 52, so that's 17 out of 52. But we know that in reality, that one of those cards we're counting here is the 5 of hearts. So really, the probability of getting A or B is really 13 out of 52 plus, now there's only 3 other 5s, so it's 3 out of 50 plus 3 out of 52, which equals 16 out of 52. So we can see that this does not work, okay, for non-mutually exclusive events. Okay, now let's look at independent events. In last lesson we were looking at two-step events, two-step experiments when they had with replacement and without replacement. I think this is a good place to start with these ones, and we can see why. So an independent event, a good example of an independent event is a two-step experiment with replacement. So if we looked at, I think we had sort of blue and red marbles, and we might have had, well, just 2 out of 5 were blue, and 3 out of 5 were red, and then we put them back. We put whatever marble came out, we put it back, and then reselect it, and we can see that we have the same probabilities for our second step. So the first event, it didn't matter which one of these was selected out first. The second experiment was unaffected. Therefore, we would say that the two events, the first selection of the marble, is independent, the outcome is independent and has no effect on the outcome of the second event. Okay, whereas if we look at without replacement rather, we'll set this up the same, blue and red. Whoops. Okay, if the blue came out and wasn't replaced, then the probability of a blue the second time is now only 1, because there's only one blue left, out of 4, because there's only 4 marbles in there. And the probability of getting a red, in this case, is 3, because there's still 3 in there, out of 4. And again, if we selected a red with our first selection, then the probability of getting a blue with our second one, because we haven't replaced the red, there are still 2 blues, but there are only 4 marbles in the bag. And again here, there's only, if we've selected out a red first, then there's only 2 left out of 4. And we can see here that these probabilities are all different from here and different from our starting points. Therefore, the first event, that is the first selection of the marble, has had an impact on the probabilities of the second event. So they are what we'd call dependent events. Okay. Now, I'd like you to have a go at exercise 13.6, questions 1 to 10. In some ways, most of these questions are almost like a revision or just of problems you've done in earlier exercises. Okay, thank you.